Greetings, I'm Ben, and in this video I'm going to show you a couple easy tips to help with data cleaning. And the first is going to be how to clean out people who fail a quality check. So we'll be using QC1 and QC2, which where we just said, hey, to show us you're paying attention, please select Ringo and please select 2. And that data is in this data file here that's named COV. So if I ask for the names of that data set, you'll see that these are all of the variables in that data. And if we look at the frequency table for those two questions, so remember they're QC1 for quality check 1. And the way I have this coded is everybody that got it right has a 0, and the people that got it wrong got a 1. And so 7 people didn't select Ringo on that first quality check item. And then if we look at the other one, table quality check 2, we see that 3,042 people selected 2 from the list of options, and 4 people selected a different number. So I have it coded so that everybody got the quality check wrong, got a 1. Now, I'm actually okay with people getting one of the attention check questions wrong. I don't really want to delete somebody unless they got both wrong. You know, I don't know, you could disagree and say, if you got any of them wrong, I'm going to delete you. That's fine. Nothing wrong with that. But my standard is going to be if you miss 2 quality checks, then we remove your data. And so I'm going to compute a new variable that is the combination of these to see how many people got both wrong. So to do that, I will just say, okay, I want you to put this new variable in the COV data, and we'll call this one just quality check. And that'll be quality check 1 and quality check 2. So now in each instance, notice I'm telling R, I want you to look in the COV data for this variable and combine these to create a new variable that you will also put in that data set. Now, I have to tell you, this data was already cleaned for people who got 2 attention check questions wrong. So if we look at the frequency table for this, table COV quality check. So if we look at the frequency table for this new variable we just created, it will be 11 people got 1 wrong, but nobody got 2 wrong. So to now clean out the people who got a certain number of quality check questions wrong, we're going to use the subset function. So I'm going to create a new data set called COV1, and this will be my data set that has the people who failed the attention checks removed. And I'm going to say, okay, use subset, the subset function of the original COV data, and we're going to use the quality check question that we just created. And so I can say is less than 2, and this will create a new data set called COV1 that is everybody in the COV who has a quality check score of lower than 2, which would mean they didn't get more than 2 wrong. Now, I could also change this to 1, and it would delete these 11 people who got it wrong. So let's do that. So now this new data set will have all the same variables, but you'll notice that these 11 people who got one of the quality checks wrong have been deleted from the data file. So that's how you can use quality checks to delete people. Now, you might also want to look at how much time people spent on a question. And so to do this, we're going to look at a different data set. And this data set's called MIC, M-I-C. And you'll see I've already computed the time variable, but we'll compute it again. And you'll notice that this has start date and end date. And so this data was collected in Qualtrics, and it automatically gives you the start date and the end date. And it measures it to the second. And so you can see how many minutes and how many seconds people spent on a study. And so this is an experiment, and we can compute a time variable. So we'll see MIC, we'll call it just T. We'll call the new variable T, because as you saw, I already did time. And so I want you to be able to, see that we're creating a new variable in that data set. We'll just call it T. And to do that, we can just say, okay, MIC end date minus MIC start date. And so this will create that variable that we want, which is just when they ended minus when they started, which will give us the amount of time that they spent on our study. But if you try to get a description of this data, so if we go describe, and I will say that the describe function is in the, I think it's in the psych package. So you'd need to make sure you have the psych package installed, which I guess real quick, if you don't have the psych package installed, you can just go install.packages psych, and then library psych, and that'll install the psych package. But I already have it installed, so I have access to the describe function. But if I try to use it, it gives me an error because the describe function is only for numeric variables, not time difference variables. And since this is these are time units, it automatically creates this as a time difference variable. So I need to get my time variable as a numeric. I can show you the table for it. It's not a great looking table. So this is the amount of time that people spent on the survey. And so you can see that the lowest value is 5.616666667 and on up. But I need to get that as numeric if I want to be able to look at the distribution or describe it or anything like that. And to do that, then I need to say, okay, take that new variable I created and make it as numeric. So what I've done here, is I've taken the old variable that is a time variable, and I'm asking it to be transformed into a new variable with the same name. So this will write over the existing variable. If for whatever reason you didn't want to do that, you could say, create a new variable called time1 or something, but we're just going to keep calling it T. So now we should be able to use the describe function, and it says, okay, the average amount of time was 16.5 minutes. The standard deviation was 7.5. The median time was 14.5. The minimum time was 5.6 minutes, and the maximum time was 47 minutes. Now, I'm fine with all of that. So if people spent at least 5 minutes on this experiment, I'm good. If people spent 47 minutes on it, that's not too much for me. Excuse me. But let's say that I wanted to trim some people out. I would use the same subset function. So let's say I want mic1 subset mic, and then T is the variable. And let's say that I want people to have spent less than 30 minutes on it, so that, well, hold on, let's look at the histogram so we can see what we're doing here. So here, let's get this bigger. Is it going to give me the histogram? There we go. Okay, so you can kind of see the distribution here where most people are in the kind of 10 to 25 minute range, and then it tapers off, and some people took a little bit longer. And if we, I guess we can also look at the table, though the table doesn't look great. Oops. And we can see that, somebody spent about 47 minutes, somebody spent about 45 minutes, somebody spent about 44 minutes. And then, of course, when we go all the way up to the top, we see these folks that spent, 5, 6, 7 minutes. So let's say I only want people who spent 30 minutes and people who spent at least 7 minutes, right? So I'm creating a subset of my original data file. I'm giving it a new name, and everybody on this new time variable that we created who took longer than 30 minutes is going to be gone, and everybody who took fewer than 7 minutes is going to be gone, because I want time to be greater than 7 and I want time to be less than 30. And so now if we get a table of the time variable for this new data set, you'll see that 29 is now the largest amount of time that anybody spent, and scrolling all the way up, 7 is the smallest amount of time. And if we look at the distribution of it, you'll see that now it cuts off at 30, and we get a little bit more precise picture of the distribution of time. So that, hold on one moment. That is all I wanted to show you in this video, just how to use the subset function to clean up your data set a little bit. Hopefully you found it useful, and it helps you prepare your data for analysis. Thanks for watching.